123, day 2. Before we get started with this section, we're going to talk about the difference between undefined and indeterminate. Probably something you should know before you head off to college. So we got the undefined versus indeterminate. Okay, we say a function's undefined when you have a number divided by 0. That's our undefined. But why is that the case? Well, let's take a look at an example. Let's take the number 15 divided by 0. If that did equal some number, then the fact family says that there's a number times 0 that should come out equal to 15. So, is there a number in your world that you can multiply by 0 and get 15? Well, obviously no. So that's why this is undefined. You cannot find a number to do that. So, undefined. Indeterminate is when we have 0 over 0. So, if it wasn't indeterminate, you would say that 0 over 0 equals some number. And the fact family says, if I just do cross products here, that there's 0 times some number that equals this top value of 0. Well, is there a number in your world multiplied by 0 that gives you 0? Yeah, all kinds of them. There's lots of solutions here. So the solution cannot be determined because there are so many of them. So that's why this 0 over 0 is the indeterminate case, because there are so many solutions to it. Here there isn't a number, so it's undefined. So a number divided by 0 is undefined. 0 divided by 0 is indeterminate. Okay. Now to the new stuff. All examples today. So we are going to find the limits algebraically. Love algebra. First one. We've got f of x equals x squared plus x minus 6 divided by x plus 3. And we are going to find the limit as x approaches, and if you look down here, you know what's coming at you, a negative 3. So, let's plot the graph. Emily, we're going to plot the graph on our paper. So, I typed it in already. X squared plus x minus 6 divided by x plus 3. Graph. Nice linear function. And I know when x is a negative 3, there's going to be that hole in the graph. 1, 2, 3. Okay. Now to find the limit. The limit as x approaches negative 3. All you have to do is plug negative 3 in. Hopefully it gives you something, but I think you can tell it's probably not today. Negative 3 squared plus a negative 3 minus 6 all over negative 3 plus 3. Let's see, 9 minus 0 over 0. There's that indeterminate form. But we are looking for this y value. And you can always use the table to check your work and know what we're trying to get to. If I look at the table, I want negative 3, and I'm going to take values really close to negative 3. And if I look, I'm at negative 5.02, negative 5.01, the hole in the graph, negative 4.9. I think I can see the limit's going to be negative 5. So we want to be able to get that algebraically, though. But at least you know what your goal is, what you're trying to get to. So algebraically, what we have to do, because we get the 0 over 0, that's called a removable discontinuity. The hole in the graph can always be removed by factoring. So we're going to factor, and because it's just a quadratic, and we know that one of the factors has to match the bottom, we did this in chapter 1, I'm just going to go right there. So, the bottom is x plus 3. I know one of the factors has to match, because that's what's giving me my 0 over 0. So now to get the other one, remember, your first times your first has to give you the x squared, so you know you have to have an x here. And the last times the last has to give me a negative 6. So that must mean this has to be a minus 2. And you can check. This will be a negative 2x, positive 3x, making the positive 1x in the middle. Because we know what that one factor is, the factoring is very easy. Now we remove the discontinuity by doing that. So the function, the equation is this line without the hole in it. It's just y equals x minus 2. If you want to prove it to yourself, hold on. Somebody at the door again. Let's see. This. Pause. Laughing at me talking to myself or what? Oh, there's the issues with that. Oh.
It like cuts off right when you start example 3.
I know, I got rid of it.
Oh.
You don't need it.
Oh, we don't
Because
need
it was messed up. Did you try to finish it? No, it doesn't
No,
work.
I how far I got.
Yeah.
That one was like 30. Yeah.
You know why? 'Cause I did this one at home, and I used Page's computer. It's a really cheap computer.
Oh.
And I bet you that's why.
Yeah. That was like, yeah. And I was trying to go through your thing before, and I was like, wait, I have to write this down now. And like, yeah.
So the voice was behind or the voice was ahead?
What's the head?
Yeah.
What you were writing was super slow. Like, and like you just got so far behind. I was like, what's
I'm not going to use that computer anymore.
Alright, it was really
I bet you that's that computer. It's the only one I did on that computer, so.
Okay.
All right,
Yeah.
Note to self. Use a good
Yeah, I
computer.
had that short. Yeah.
I was like, what? All right, yeah, don't worry about example 3.
Okay, thanks.
Okay, I'm back, and I don't really remember where I left off. But I know we factored, we removed the discontinuity. Now to find the limit algebraically, we're just going to use that as x approaches negative 3 of now just the remaining factor, x minus 2. So plugging the negative 3 in for x, negative 3 minus 2, there's our negative 5. Oops, sorry again. The limit as x approaches negative 3 of just the remaining factor, x minus 2. Plugging in negative 3 minus 2, and negative 5. And that's what we thought we should get from the table. I'm just going to practice this skill today, but the factoring is going to get a little bit more challenging. You're going to have to use that skill you learned the other day. Okay, example 2. Same thing, finding the limit algebraically for f of x equals x cubed minus x squared plus x minus 1 all over x minus 1, and we're going to let x approach 1. Again, sketch the graph, show the discontinuity at 1. So we'll go y equals, turn on, clear that out, x cubed, minus x squared plus x minus 1 divided by x minus 1. Okay, nice parabola, and if you trace to 1, we should get an error, no y value. So at 1, there's going to be a hole in the graph. we look at the table to figure out what that limit might be, table set, I want it to be at 1, and then values close to 1. Looks like it's on the y, 1.9 to 2. Looks like it's jumping over the number 2. So we get something close to 2, we probably did it right. So here we go. The limit as x approaches 1 of x cubed minus x squared plus x minus 1 over x minus 1. You do need to show the substitution and show what it comes out equal to. So 1 cubed minus 1 squared plus 1 minus 1 all over 1 minus 1. 1 minus 1, 0, 1, 0 over 0. There's our indeterminate form. We can remove that discontinuity. I know that x minus 1 is one of the factors, but this is not a nice quadratic where the other one's binomial. To find the other factor, you're going to use that synthetic division, your Gazinda box that you learned the other day. So we're dividing by x minus 1. So you take the opposite of this a term, which is 1. Make your little Gazinda box. Then you need all of the coefficients, starting with the highest one and down. So that's positive 1. Next one's negative 1. Positive 1. Negative 1. Okay. Raise the first one. Nothing goes below it. Multiply, add, multiply, add. So multiplying 1 times 1 is 1. Adding 0. Multiplying, I get a 0. Adding, I get 1. Multiplying, I get 1. Adding, I get 0. It has to go in evenly, that's why we're getting the 0 over 0. So if you don't get 0 here, you did something wrong. So the other factor is, starts out 1 less than what I'm dividing into, so it's 1x squared, plus 0x, which I'm not going to write down, plus 1. So now I can cancel off the x minus 1. Now to get the limit, as x approaches 1, I'm just going to use the x squared plus 1. Substitute in, 1 squared plus 1, there's our 2. Let's try one more, actually 2 more. F of x equals x cubed minus x squared minus 5x plus 2. Divide by x plus 2. And we are going to approach negative 2 and find that limit algebraically. Plot the graph first. Clear all that out. X cubed minus x squared minus 5x plus 2 divide by x plus 2. Graph. Nice parabola again, but when x is negative 2, we've got that hole in the graph. So looking for the limit, we'll go to the table. I want the limit at negative 2. Look at the values there to see what I should be getting. Looks like the y values are jumping over 11.